So you're a developer here at Wex, and you know building a new service is a pretty big deal. It's not just about spinning up some code, it's about plugging into this massive, living, breathing platform. So how do we make sure every single service we build is tough, scalable, and ready for production right out of the gate? Well, that's exactly what we're going to dive into, the core design guidelines that make it all happen. And, this quote really gets to the heart of it. These aren't just some rules in a dusty corporate handbook. This is wisdom that was paid for, as it says right there, in the blood and tears of developers who tackled Wix's incredible scale head-on. The whole point of this is to share those lessons so you can skip the pitfalls and build smarter from day one. Okay, before we touch a single rule or write a single line of code, we have to ask ourselves the most important question of all. What's our North Star, right? When we're faced with a design choice, what's the ultimate goal we're trying to reach? What's so interesting here is that all of these big goals, building an open platform, having APIs people can actually reuse, moving fast, and being super resilient, they all force our hand. They all push us towards one specific architectural decision. We have to build services that are decoupled and composable. And that one idea, well, that's the bedrock for our very first and maybe most important guideline. This brings us straight to the most fundamental challenge any developer faces when they start something new. How do you draw the lines? How do you scope your service so you don't accidentally create a mini monolith that you'll regret later? It's the classic Goldilocks problem, right? Is it a macro service, a nano service? What's the just right size that actually helps us hit those North Star goals? You might be surprised, but the answer is incredibly simple. 1. That's it. The answer is 1. The rule is just that simple. One main entity for every service you deploy. Now, what in the world is a main entity? Just think of it as the core business concept your service is in charge of, like a product in Wix stores or a booking in Wix bookings. It's the thing that has its own life cycle, its own story. Sticking to this one-to-one rule is our number one defense against creating what we call a big ball of mud. And this is exactly why we're so strict about this. It forces you to decouple things from the very beginning. You literally can't create those sneaky, hidden dependencies when services are truly separate. And that is what lets different teams scale and deploy whenever they want. Which, if you think about it, is the whole point of building this open, reusable platform in the first place. All right, let's take the next logical step. You've defined your service boundary, you've got your one entity, so how does it talk to all the other services out there? More specifically, how do you handle data? This one's a biggie. The rule is absolute. Your service cannot, under any circumstances, ever reach directly into the database of another service. Not gonna happen. All data has to come through that service's official public API. This is what protects us. It lets teams change their internal schemas without breaking half the company, which, of course, leads to the immediate follow-up question. Okay, fine, I can't touch their database, but I need their data to do my job. So what are my options? What are the patterns for actually reading that data? This table lays out the trade-offs beautifully. I mean, sure, you could just make a bunch of separate API calls. That's easy, low complexity, but the performance is going to stink, and forget about trying to filter on another service's data. It's impossible. On the other end, you've got materialization, basically keeping a local copy of the data you need. Yeah, it's more complex to set up, but look at that big green check mark. It's the only way you can do cross-entity filtering, which so many of our coolest features rely on. So it all comes down to this one question. Before you even think about writing code, you have to ask yourself, do I need to filter my stuff based on that other service's data? If the answer is yes, your path is chosen for you. You need materialization. Making that call up front is one of the single biggest architectural choices you'll make, and it'll save you a world of pain later.
Okay, reading data is one challenge, but writing data across multiple services, that's where the gloves really come off. This is where the true complexity of distributed systems rears its head, and we have to be incredibly careful with our design.
Now, this rule right here is probably the most shocking one for developers who come from a monolith world, but it is a non-negotiable law at Wix. We do not ever use distributed transactions. Why? Because they create brittle, tight coupling, they hold database locks, and they become a massive single point of failure. We have to design for a world where things fail, because they will. So if you can't have a big transaction, what is your transaction boundary? It's simple. One atomic write to your service's own database. That's it. Full stop. Any other work, like calling a different service or sending an email, must happen asynchronously, completely separate from that initial request. This leads us to a really clever and resilient solution we call the zombie pattern. Just follow the flow here. First, your one synchronous write just creates the entity in this harmless pending state. It's a zombie. It exists, but it can't do anything, can't hurt anyone. Then you fire off an event to trigger the async work. An async handler picks it up and does all the risky stuff, like calling the payment service, and only if that succeeds does it come back and, in the final step, bring the zombie to life by flipping its state to active. If any of the async parts fail, who cares? You're just left with a harmless zombie, not a corrupted system state. It's brilliant. Now look, we know that the ideal async pattern takes a bit more work. So yeah, there are shortcuts, like just making a second synchronous call. But you have to go into that with your eyes open and understand the risk you're taking on. If you do that, you lose all the automatic retries that Kafka and our async queues give you. If that second call fails, your system is now inconsistent. You're trading resilience for speed, and that's a trade you should only make for things that are not business critical.
Okay, let's bring it all home. In our final section, we're going to see how all these pieces fit together to help us build services that aren't just well-designed, but are truly production-grade, tough as nails, and high quality.
You should think of this list as your production readiness mindset. Resilience isn't something you bolt on at the end. It has to be designed in. Take degrade gracefully. If a service that provides user avatars goes down, does your whole page crash? Or do you just show a default gray circle? That's what designing for resilience means. Every single point on this list is about expecting failure and already having a plan for it. So how do you actually build confidence that your code does what you think it does? Well, your main feedback loop, your best friend, should be what we call in-memory hexagon tests. The core idea is simple. You test your service like a black box. You only talk to it through its public API, just like a real consumer would. These tests are lightning fast, super reliable, and they prove that your decoupled component actually works like a decoupled component. So I'll leave you with this final question. It's really the challenge that all of these guidelines are posing to every single one of us. Are we just building a feature to get a ticket moved to done, or are we building a foundational, reusable, resilient component that strengthens the entire Wix platform for years to come? That difference in mindset, that's everything.